Hello, this is Mr. Stein, and in this video, we're going to look at section 7.1, developing a system of linear equations. By the end of this, you should be able to write linear equations from a situation and identify restrictions on variables. Let's look at the vocabulary and the basics. The first vocabulary is, what is a system of equations? All right, a system of equations is two or more related equations. How are they related to each other? Well, they're related to each other by whatever the question says. I'm going to give you two examples, two equations. We're going to say that they're related, and all we have to do is say these two equations are my related system. So here's equation number 1, y equals 2x minus 2. That's one linear equation. And my other one is y equals x plus 1. So these two are related. Now when we have a system of equations, so we have two or more related equations, we try to find the solution that they share. Right, so we're going to look at the solutions to the first equations, y equals 2x minus 2. We can do this in many ways. We can do a table of values. So I've got my x and my y. I'm going to plug in some values for x. So 0, 1, 2, 3. Now we figure out our values for y. When we put 0 in, 2 times 0 is 0, minus 2 gives us a value of minus 2. Now we put 1 in for x. 2 times 1 is 1. 2 times 1 is 2. Minus 2 is 0. Now we put 2 in for x. 2 times 2 is 4. Minus 2 is 2. And 3 will give us 6. Those are different possible solutions for our pink equation. Now we look at our green equation. We'll build a table of values. 0, 1, 2, 3. We put 0 in for it, and 0 plus 1 is 1. So our solution there is 0, 1. We put 1 in for x. 1 plus 1 is 2. Now we put 2 in for x. 2 plus 1 is 3. Now we put 3 in for x. 3 plus 1 is 4. And now we look. Do we have any solutions in common? And we would if I wouldn't have made a mistake. Let's take a look right there. 2 times 3 is 6, and then I forgot to minus 2. This should have been 4. Yes, we do have a solution that's in common. So these two share a single solution. So the solution that works for both of these equations is when x is 3, y is 4. Now we're going to take a moment and graph these. So I'm just sketching a graph right here. All right, and let's start by graphing. Let's graph the pink one, 2x minus 2. So right there, then 1 and 0, 2 and 2, 3 and 4. The first one looks like this. Y equals 2x minus 2. And our second one, y equals x plus 1. So I'm going to graph that in green. So we start here, 1 and 2, 2 and 3, 3 and 4, right there. See those graphs cross right at our solution. Our solution is the point at 3 and 4. So when we have two or more related equations, we write them out, and then we look for the solution that they share. We can do that by guessing with a table of values, or we can do that with a graph. Now in this section, we are going to practice taking a situation and writing a system of equations. So let's take a look at this first scenario. A rectangle has an area of 60 square centimeters. It has a perimeter of 38 centimeters. What are the length and the width of the rectangle? Okay, so our first step. Step number 1. We define variables. Our variables are what we're trying to find out about. We're trying to find out about the length and the width. So L equals length of rectangle and W equals the width of the rectangle. Those are our two variables. We've just defined them. Step number 2. We're going to look for the restrictions on the variables based on the scenario. So in this question, L has to be greater than or equal to 0. We can't have negative lengths. So L has to be bigger than or equal to 0. And L could be any real number. Because, well, it could be decimals, could be fractions, could be any real number. So we can just write this like this. L such that L is greater than or equal to 0, and L is an element of the real numbers. Now, our width variable would have the same restrictions on it. W such that W is greater than or equal to 0, and W is an element of the real numbers. So we've identified we've defined our variables, we've identified the restrictions on our variables. Now we can write our equations. So let's write out our equations. The first one comes from this section right here. A rectangle has an area of 60 square centimeters. So we are going to get this equation. Length times width is equal to 60. That's equation number 1. Now, our second equation is going to come from this part right here. It has a perimeter of 38 centimeters. So our second equation is, well, whichever formula for perimeter you use, I'm going to use twice the length plus twice the width will equal 38. These are our two equations that are related that come from this situation. Now, in this section, all we're doing is this amount here. We're just doing this. What we have here. We are not solving the system of linear equations. We will work on techniques to solve the linear equations in the next sections. But in this section, all we're doing is defining our variables, restricting our variables, and writing equations from the given situation.